All right, if I could have your attention for a few minutes. I thought today, instead of showing you something from the lab, it might be useful if I show you how to use JUnit for doing one of the homework problems. So let's just dive right into that partitioning thing that we talked about before. So here I just copied from I made a new project, homework 6b. I just dumped the class in here. I commented out a couple of things that wouldn't compile because of the dots, because I do want it to compile. And so here I have the partition method. I didn't do any work yet. Down here is the move regions. We're just not going to worry about it yet. I want to test partition. So it's a good idea to make a test. So I made a new unit test simply by over here clicking new JUnit test, just like you've done before. And so it puts these junk things on top that I don't care about right now, and it invites me down here to put a test. So and at first, when one does this, one doesn't normally even know what one should call it. I'll call it test 1, and I'll change the name later. So I want to change partition. So I want to test partition. So I need to make myself an array, and so here I'll just make an array. I make a new quick sorter. Of values, and now I want to call partition from and to. I'll just pick right now. I'll just pick the whole thing from 0 to q to values at length -1. And now what do I want to test? It's now supposed to give me these 3 regions. So I might want to test that everything in the middle region is actually less than the pivot. So the middle region extends from, it says here, from B0 plus 1 to B1 minus 1. Okay, so these are all that I want. So that would be, goes from B0, that would be now R0 minus 1. Okay, goodness, what was it? Okay, R0 plus 1, B1 minus 1. R0 plus 1, minus 1. And I want to say assert true, okay, that the element in the array that we values I is less than the pivot. Oh, I have to put an I++ here. And that's all I want to do. I need to set the pivot. So the pivot was value 0. So I'm just kind of randomly checking one of the things that I should be checking. Now I can just go ahead and run it. So here, let's run this test case. Run file. That's not good. So it's not running at all. It's not stopping at all. So that probably means that I had an infinite loop somewhere. So let's figure out how we can terminate it. Okay, let's close it. Okay, so that should have terminated. So the reason for that is that, of course, over here I have this loop condition that says while I less equal than j, and I've never changed I and j. So I guess I do have to put in a little bit of work here. Okay, so if AI is less than the pivot, then I think I just want to then I just need to extend my area. If AI equals the pivot, then I need to swap. What does swap take positions? Yes. Then I need to swap I and I0. And I guess I also need to increment. If J is greater than the pivot, I just decrement this. What's that? You say I should increment I0? Okay, well, we'll just code by acclamation here. Here, if it's... I guess then I'll just do it symmetrically. And then over here, if they're the same, then I swap. Alright, so now let's run the unit test again. Okay, so it failed with an error and with an array index out of bounds exception. I see, and that's because I probably didn't even return any answer here. That's right, I just returned an empty array here. That wasn't so good, so I probably want to return I0, J0, looking at this picture here. So now let's run it again. And now, something passed. So that's good. So apparently, for whatever reason, this test passed, and now I can keep on going and test the next area and see if all of those are greater than the pivot. So this would be R1. And now I have to be careful to see how far do I go. I go to R2 minus 1. And now I want to see if they're greater than the pivot. And I run my test again. And it runs and it passes. So now I want to check that the ones that are all the way to the left, that they equal the pivot. So that's from 0 to R0. And I want them to be able to be equal to pivot. And that also passes. That's amazing. It doesn't usually work this smoothly. And then I want to check the ones that are from R2 that go up to T, that they're also equal to the pivot. Oh, it doesn't know what T is. Values length minus 1. Or and that's almost too good to be true. So what I want to point out here is, notice that I've never written public static void main. Nothing in my code has a public static void main. All I did is I copied the quicksorter. I filled in the partition method to the best of my abilities, together with some help here from the seats in the front. And then I put in my test case, and then I just run it as a test case, and the green bar says that all of these things that I'm asserting here are correct. Now, it does sound kind of too good to be true, so I'm also going to print out arrays, toString, the values. So nothing stops you from printing in a unit test, and it'll print in the normal. Oh, thanks. Oh, I thought I imported it. So now it prints over here, and I see 22001144. So I guess it would also be a good idea to print out the indexes that it returns. So it prints indexes 1, 6, and 10. This looks awfully plausible. So maybe I did too good a job, because normally what happens when I do this, I kind of find a couple of errors, and then I can use the unit test to fix that. Now, of course, you might say that's just one array. So now you might start looking at some special cases. So let's say I wanted to look at the case where on the pivot only occurs once. So that means that everything else doesn't have a true. Then I could just make another test case for this. And at this point, I've started having an idea what I want to test for, so I call it pivot only occurs once. And so then I would change all the trues here to something else. So let's run it. And it also passes, so that's great. So at this point, I could say, well, what other things could happen? I could say, well, one weird case might be, what if nothing is bigger than the pivot? Well, then I could just make the pivot 200, and then nothing would be bigger than it. And 3 tests passed. So at this point, I'm beginning to feel pretty good about that I might actually have a correct solution. And notice that I was able to do all of this in what? 7 minutes? I didn't have to write a main program. I didn't have to read input. I didn't have to write output. I'm just testing a single method, namely this partition method. I'm not yet worried about what happens to that other method. But by doing that, I'm now getting some level of confidence that this is right. Now, this is unlikely to happen to you, and I'm surprised that it happens to me. Normally what happens is that something goes wrong, and then I can kind of narrow down and come up with a test case that does that wrong. I just leave it in there. Now, at some point you might say, this is all a little, what's ugly about this setup here that I've been doing is there's all of this repeated code. But it's Java code. You can simply make a regular function. I'll call it check partition, and it gets an array of values. And all of the common stuff I'll put in here. That would be all of this stuff here. And then this one here, I would just call that method. And over here, I would do the same thing. In fact, I can just pass the array to it like that. Here's the same thing, check values. So now it looks a little pretty. All I did is I took out the duplication by introducing this method. Notice that this method is not annotated as test. So it's not a test case, it's a helper method. Come on. Tasks. It's not called check. Oh, because it's not static. No, it shouldn't have to be static. Oh, I see. I think it's easier to change it here. Okay. Let's do it again. Run as So now, of course, they still pass the same way. And now it could, come up with, like another nasty case might be, what if they're all the same? And I would run that, and they're still all passed. This never happened to me before. But you see, this way you can build a set of test cases, and it's really a pretty simple thing to do. What was the hardest part? The hardest part was to come up with what do you want to test. And so here we wanted to test, is everything equal to the pivot? And the next thing, is everything less than the pivot? Is everything greater? And then again, is everything equal? Well, that's exactly the kind of condition that we want. The loops are simple. Assert true means I want this to be true. Just to show you how something could go wrong, let's say over here I had messed up my indexes and had returned like I plus 1 here. Then a bunch of these test cases fail, and then I can look at C and see. In fact, this one caused an error, this one caused an error. Then I can look up what failed. This is a little artificial because I introduced this just to show what goes when something goes wrong. But so it gives you an idea on how easy and how powerful it is actually to use these unit tests. Once you're familiar with how to set them up, it is simpler to write a unit test than it is to put in a public static void main. Then that way you can put in as many tests as you like. So I highly recommend that you just do it on your own initiative for this homework, and do it as soon as you find the first error. You're not going to be motivated until you find an error, but once you find the first thing that's hicking up, try to put in a unit test and see how it goes for you. It really is a powerful tool.